Now let's learn a little bit more about Spark and its ecosystem. So in the big data ecosystem, I had shown you the diagram of Spark, right? So what happens is that we have these storage layers, and on top of the storage layer, we have clusters and resource managers like Yarn, and Spark sits on top of it. And in Spark itself, there are multiple layers. So let's start from the storage layer. Now, when I talk about storage layer, I'm talking about both batch and stream processing. So here you see I have relational databases, NoSQL databases. I have file systems, distributed file systems like HDFS. I have files like Parquet, CSV, JSON, Avro, etc. Then I have streaming ingestion technologies like Kafka, Kinesis. And it can also be data warehousing technologies like Redshift, Snowflake, BigQuery, etc. This is the storage layer. I know it might be a little confusing because I have put Kafka and Kinesis also in the storage layer, but it is essentially where you get the data from. So this is the data generation layer. And then we have this cluster which is attached to this data generation layer. So using Spark that is running on the cluster, we can connect to all these data generation technologies. And then we have Yarn on top of it. Then when we write a Spark code, we submit the code to Yarn, and Yarn does the resource management and runs the Spark application code in the cluster, which would read data from any of these data storage layer. Now this is the Spark code I'm talking about, not the Spark ecosystem by itself. In the Spark ecosystem, what we have is, we have something called Spark Core API, wherein RDDs or resilient distributed datasets sit. So this is the core API of Spark, meaning that this is the low-level API which would actually communicate to all of these storage layers. It can be relational database, NoSQL databases. It can be data warehousing systems, cloud distributed storage like S3, GCS, or batch files like Parquet, CSV, Avro, etc. Or can be stream processing layers like Kafka and Kinesis also. So this is the Spark Core API. But we do not write code on Spark Core API because as per the new versions of Spark, we should write application code using the higher level API, which I'm going to talk about shortly. But still, I will discuss RDD because RDDs are the building blocks of Spark. If you understand RDD, then it would be easier for you to understand the higher level APIs like data frames, SQL, etc. Now on top of Spark Core API, we have the data frame API. And data frame API is the one that is recommended to be used, meaning that if you are writing code, we should use the data frame API, not the Spark Core API. I'll talk about it why it is needed in the later videos, but as of now, what happens is that the data frame API sits on top of the Spark Core API. What it means is that even if you write using data frame API, those will be converted to Spark Core API. And data frame API provides data frame writers and readers also, which essentially can be used to read or write from and to these storage layers. The read and write are not direct. The data frame reader and writer gets converted to Spark Core API, and that does the reading and writing. So Spark Core API is the heart of the Spark system. When Spark started, we used to write code using RDDs, but now we do not do that anymore. We write Spark code using data frames. And on top of data frame, we have Spark SQL, we have structured streaming, and we have machine learning libraries. So what do you infer from this layer? You can pause the video and think about it. So what happens is that you can write the code either using Spark SQL, you can write the code using structured streaming or using Spark's machine learning library, but eventually it gets converted to data frame API and then to the Spark Core API. But actually, it is not that that SQL would be converted first to data frame API and then to Spark code. That is not the case. It is directly converted to Spark Core API. But these layer, the Spark SQL actually sits on top of data frame because Spark SQL has also been created using the data frame APIs only. Same is the case with structured streaming and machine learning libraries. So this is the Spark ecosystem, wherein Spark Core API or RDDs sit at the bottom doing all the work, and we write code using data frame or Spark SQL or structured streaming. And the programming language that can be used are Scala, Python, Java, and R. We'll be talking about Python only. I'll not show you Scala, R, or Java. So we'll write Spark code using Python and its library called PySpark. So this is the Spark ecosystem. So the left-hand side is not the ecosystem. The right-hand side is the ecosystem. Left-hand side is the hosting platform. The cluster that you see here and yarn on top of it is called the hosting platform. And there are multiple hosting platforms for Spark. And the question is, what is a hosting platform? The general definition of hosting platform is that it is used to host a tool or framework or application or software. That's what a hosting platform is. So Spark is a software or Spark is an application. You might want to call it anything. You have to host the software or install the software and then write the code and then execute it. So we have multiple hosting platforms like AWS EMR. In Google Cloud, we have Dataproc. Then we have Databricks also. Databricks is a lot more than hosting platform itself, but Databricks also provides hosting platform using AWS, GCP, or Azure. Now, there are a lot of other tools that Databricks provide. So that's why when you go to the Databricks documentation, you'd see that it is a data intelligence platform or something like that. But it gives you a hosting platform also using the cloud service providers. Now, what I mean by hosting platform? So let's say I have this cluster. What is a cluster? It is a group of servers. If you are using AWS, it is a group of EC2 instances, which you have already seen in the EMR hands-on when I had shown you HDFS. If it is Google Cloud, then these are all Google Cloud Engine instances or GCE instances. So these are either physical or virtual servers. These boxes, white boxes, are physical or virtual servers. So that's what a cluster is. And cluster is a grouping of these physical or virtual servers. Of course, they have connectivity among each other. So all the nodes are connected to all the other nodes. And you might have guessed that this is the master or the primary node, and these are the compute nodes. To make this cluster a hosting platform for Spark, what we have to do is that we'll have to make sure that if we run a Spark application, that should run in this cluster. So for that, we'll have to install Spark in all the machines or virtual machines or virtual servers. Of course, there would be other softwares also like Hadoop, Yarn, etc. But to make it a full-fledged Spark hosting platform, we'll have to install the Spark software in all of these machines, which can be physical or virtual servers. Physical servers would be on-premise and virtual servers would be like EC2, GCE, etc. Let's say you have 60 compute nodes and you have a primary node. So do you install Spark in all the nodes? Do you install Yarn on all the nodes? Do you install Hadoop on all the nodes? What about HDFS? What about connectivity between the cluster and the cloud object storage or cloud distributed storage like S3 or GCS? That's a lot of work. That's a lot of repetitive work. So that's why we get managed services like AWS EMR or GCP Dataproc or Databricks. These are the various cloud hosting platforms for Spark. We have on-premise hosting platforms also like Cloudera, Hortonworks, etc. Both Cloudera and Hortonworks provide hosting platform on the cloud services also like AWS, GCP, and Azure. So this is called a hosting platform for Spark. So you need to have all the softwares, all the big data softwares along with Spark. And we can have our local machine also as a hosting platform. Now, when we learn Spark, we should start learning on the local machine first. Then we should go to the hosting platforms. So that's why I'll be installing Spark on my local machine. I will write all the codes in the local machine. When I increase the complexity of Spark applications, then I'll go to the hosting platforms like EMR or Dataproc. All right, so that's what hosting platform is. Now, all these are platforms and ecosystem and services that I have talked about. What about writing the code itself? So that's what Spark development is. And what we do is that, as I had shown you earlier, that we write the code using Python or Java or Scala or R. I'll be using Python and Python's PySpark library. So we write the code using these programming languages these 4 programming languages: Python, Scala, Java, and R. And as I said, I'll be using Python. So the IDE would be PyCharm. You can use Visual Studio Code also, or you can use IntelliJ also. That's your choice. But I'll be using PyCharm. So for Spark development, we use a programming language and an integrated development environment like PyCharm. So if you're using Java or Scala, you can use Eclipse. So that would be your IDE. And you can use the programming language either Java or Scala. Same would be for R also. So this is how we do the development. We use or choose one of the programming languages and one of the IDEs. The IDE helps us in code development. It assists us in code development. Now, how do we fit all these things together? The IDE, the Spark ecosystem, Yarn, and the cluster. So I'll start from the end, the cluster. So this is the cluster that we have. If you are using EMR, then these are all EC2 instances. This is the primary node and these are the compute nodes. I have 1 primary node and 5 compute nodes. Now what we have to do is that we'll have to install Yarn in all the nodes. Again, if you use EMR, we do not have to do any installation. The installation would be done by AWS automatically. If you are using Dataproc, then again, we do not have to do any installation. It will be done by Google Cloud automatically. Once we install Yarn in all these, the components that gets implemented on the primary node is called Resource Manager, and the component that gets installed in the compute nodes is called Node Manager. After that, we'll have to install Spark on top of it. Of course, Hadoop should also be there. We'll have to install Hadoop and then we'll have to install Spark. We do not do it. It is again done by the hosting platform. So if you're using managed service, what we do is we launch an EMR cluster or a Dataproc cluster, and what those services do, what those managed services do, AWS would install Yarn, Hadoop, Spark, etc. in the EMR cluster, and Google Cloud would install Yarn, Spark, etc. in Dataproc cluster. And if you're using local machine, we do not need Yarn. We'll use Spark's standalone resource manager, which we'll talk about later on. So this is the cluster plus Yarn plus Spark. And Spark does not end here because we write Spark code using an IDE like PyCharm, and we write Python code, which is essentially PySpark code. And then we run this PySpark code or deploy this PySpark code in the cluster. How do we deploy? Again, I'll show you that later on, but we write the code on our local machine and we use some deployment tools to deploy the code in the cluster. While deploying, we mention when do we want to run the Spark code, and then the PySpark code would run automatically based on the schedule that we have provided. So this is the entire picture for us developers. We create the cluster using EMR or Dataproc. The softwares like Yarn, Hadoop, Spark, etc. are installed automatically for us by EMR or Dataproc. And then what we do is we write Python code or PySpark code using one of the IDEs like PyCharm or Visual Studio or IntelliJ or Eclipse. Then we submit the code to the cluster. When you do the practice, we'll be doing it in the local machine, wherein I'll not install Yarn, I'll install Hadoop and Spark. Spark also has its own resource manager, which I'll discuss later on. So I have talked about Spark ecosystem, I have talked about the Spark development, then cluster creation, Yarn, etc. Now, how Spark executes. So once we submit it to the cluster, how Spark execution happens. Now here I'll give you a high-level overview, because before writing the code, before going into hands-on, we should have a high-level idea on how Spark codes get executed in the cluster. Then we'll do the coding and then we'll go deeper into the Spark execution architecture later on also. And this is a familiar diagram which I had shown you in the big data processing section. We have 4 nodes, node 0, node 1, node 2, node 3. Then there's resource manager and node manager. What happens is that we submit an application code. It can be MapReduce, Spark or Flink. Then the code is submitted to the resource manager. Resource manager finds out one of the nodes which is available with the resources. Then it talks to the node manager and then starts the application master. Then application master communicates back to the resource manager saying that I need so and so resources. this much amount of RAM and this many number of CPUs. Then if those resources are available, resource manager would communicate with the node managers and then launch the application code. This is the architecture of Yarn. Now if I superimpose Spark here, this is how it would look like. Nothing changes. The only two things are, first I have changed the color code. Second is, if you see here, instead of application master, I have mentioned Spark driver, which is actually the application master for Spark code. And then we have user code, which runs in the other containers. And these are the application codes vis-a-vis Yarn. So what we do, we submit the Spark code or PySpark code to the cluster. It goes to the resource manager. Resource manager talks to the available node manager wherever resources are available. Then the node manager would create a container or launch a container and start the Spark driver code there, which is the application master for Spark. Then Spark driver would communicate back to the resource manager saying that I need 4 containers to launch the user code. And then resource manager would say, yes, I have resources available. I have to go to all the nodes, node 1, 2, and 3. Then it will go and talk to the node managers in node 1, 2, and 3. And then the node managers would launch the container and start the Spark user code there. When I say user code, this is the portion of the code that we write. Driver code is something that is handled by the framework, and the framework is Spark here. And the portion or the program that actually runs the user code is called executor. So the application master in Spark is called Spark driver, and the application code in Spark is called executor. So executor actually executes the user code in the cluster. So this is the Spark execution architecture, and it fits really well with the Yarn execution flow that I had discussed earlier. This is the Yarn execution flow, wherein we have application master here and application codes here, and this is the Spark execution flow or Spark execution architecture, wherein the application master is this one and these are the application codes. Application master is known as Spark driver, and user codes are executed by executor. So this is called a driver process. This is called an executor process. I'll go deeper into driver and executor process later on. All right, so now if you see, this is actually the master of Spark. This is the brain of Spark. And then these are the user codes. These are the hearts of Spark. So the transformation logic would actually be there in the user code. The executor would execute the transformation logic, not the Spark driver. So now what am I going to do is that I will remove everything, all the noise here, and just talk in terms of Spark. Now in this particular diagram, Spark is the red box and the blue boxes. So let's take a look at Spark architecture now. Obviously we'll need resource manager, and we have Spark driver, and we have executor. Now if you notice, I have changed the name of the nodes to worker node, and this is Spark lingo. The nodes where executors get executed are called worker nodes, or where the Spark driver runs, that is also called a worker node. So what happens is that, as I had told you, that we submit the code that we write to the resource manager, and resource manager would start a Spark driver application or Spark driver process in one of the nodes. In our case, this is worker node number 3. So this is where Spark driver has been started. And after the Spark driver has been started, it would talk or communicate to the resource manager. This is the first step vis-a-vis Spark only, not Yarn, not Hadoop, not MapReduce. This is the first step of Spark. Once the driver process starts, it will talk to the resource manager asking for resources, meaning CPU and RAM, saying that I need so many containers because I have so many partitions. I need to execute so many executors. I'll talk about executors, partitions, and their mappings later on, but try to understand the high-level flow here. So Spark would say to the resource manager that I have 4 executors or maybe 8 executors, and I need resources for all the 8 executors. So resource manager would say, see, I do not have resources to run eight executors, but I have resources to run 4 executors. I can run the 4 executors now, and the remaining 4 executors of yours can wait for some time. Once the execution of these 4 are done, I can execute the next 4 executors. And then Spark driver would say, okay, let's go ahead and do that. Resource manager will talk to the node manager of worker node 1, 2, and 3, and then all the executor processes would be started, which will execute the user code or the actual application. Once the processing is done for this particular executor processes, then they would be terminated. Then the next 4 executor processes would come and run the same way. So this is what the Spark architecture is at a very high level. So as you can see that Spark architecture contains 2 major components. The first one is driver process. Why it is a process? Because process is nothing but a program that is getting executed in a cluster. So if you have a program, you save the program in your disk, let's say, and when you execute it, when you start the execution of the program, that gets executed by the CPU using memory. Then it becomes the process. So any program that is getting executed by CPU is the process. So that's why it is called a driver process, because it is getting executed by one of the worker nodes or by the CPUs of one of the worker nodes. And these are the functionalities of driver process. First, it coordinates with resource manager for compute resources, which I've already told you that once the driver process is started, it will talk to the resource manager asking for compute and RAM to start the processing of executor processes. On top of it, what it would do, it would analyze the code and create something called execution plan. We'll talk about execution plan later on, but just to give you an idea that this execution plan is created by the driver process. Execution plan is nothing but the access plan, how the code would be executed physically. That is created by the driver process. Then it also schedules jobs and tasks. Now jobs and tasks are Spark terminologies. We'll talk about jobs and tasks later on, but these are related to the executors. So essentially it will schedule the executors, saying that, okay, resource manager has given me the resources, let me go ahead and start the executor. So once the executor is started by the node manager in the container, the executors will always communicate with the driver process to track the status of the jobs, and if there are any failed tasks, that would be replaced by the new tasks by Spark driver. So the driver would track the status of the jobs, what is the current status, whether it is running, it is pending, or it has failed. If it has failed, then Spark driver would start one more executor, obviously after communicating with the resource manager, and then the new executor would be replacing the executor that has failed. Now all these things are part of or are done by the driver process, and we do not have to write anything. These are provided to us by the framework. Then we have the executor process, and the main purpose of executor process is to run the actual transformation code based on the access plan provided by the driver. So when we submit the code, the access plan is created by the driver and it is sent to all the executor processes by the driver. And then when the code is sent to those worker nodes or to the executor processes, they would execute as per the access plan. So that's what introduction of Spark is. And in the next part, I'll go ahead and set up Spark in my local machine.